Okay, let's talk a little bit about translations. So translations, guys, just move your graphs up and down, okay? And we kind of do it similarly to what we did in the previous examples with the stretch. So if I look at the absolute value graph, and I'm just using the same points. Again, you can find these in your previous section of notes. And if I just wanted to translate these four spaces downwards, okay? So this -4 makes me go down 4 units. And so basically we just take the y values and we're just going to subtract 4 from every y value. And we'll just leave the x values alone. So I'll just copy these back down. And what we're going to do is we're going to subtract 4 from our y values, which is the second column. So we get something like this: -2, -3, -4, -3, -2. And we'll just graph both of these so we can compare them. So the original graph roughly looks like this. It is a V shape. Okay, and I know my drawings are not the prettiest on here, but it meets at the origin like that. And our new graph will be a little nicer about graphing this: -2, -2, 1, -3, 0, -4. And you can see this one makes that same V shape, but it is shifted down 4 spaces. Okay, so just something to note. Again, the absolute value plus or minus whatever goes here, this is going to be a up and down change. Okay, and it is going to affect the y values. Okay, so if you want to shift left and right, now that's going to be a horizontal translation, and we're going to come see that next. But vertical translations are always tacked on at the end of the function. So in this case, we deem the original function, the baseline, to be the absolute value of x, and that -4 is a transformation on that, which moves it down 4 spaces. Okay, and this can be sometimes called a shift. It's also called a translation. You can see in the green box, there's a handy reminder about how to use vertical translations and how you can identify them. Here is a nice visual also of vertical translation. So you can see, hey, here's a +2, -3, and then the original function. And you can see how it slides up and down based on that. Okay. And let's look at a horizontal transformation here. So same function we've been talking about the whole time, the absolute value. And again, I know I'm sure you guys are tired of me writing this out, but it's just the same ones that we have been using. Okay. But this time, this x -4 is going to make me move right 4. And you might say, wait a minute, -4, shouldn't that move in the negative direction? Shouldn't it move to the left? But just remember, everything in the parentheses is always opposite. So in this case, inside the absolute value lines, I should say. Okay. And so when I come do this, what we're going to do is we're going to add 4 to the x values. So here is x +4 instead of -4. And then we're going to leave the y values alone this time. Okay. So again, that is a horizontal change. It's going to affect the x values. Okay. Let's make a little note here again. This is always opposite. So that sign is always flipped around. Whatever rule you use to remember it, just remember all the transformations that are horizontal are always going in the opposite direction. So there's going to become 2, 3, 4, 5, and 6, and our y values are unchanged. And when we graph this, you'll see it's a little bit of a different looking thing. So here's my original one. And if we shift it to the right 4 spaces, we'll see what this one looks like. And so here we can see the shifted right graph. Now, this is a horizontal transformation. It shifts to the right. Again, every time you look inside of the function, right? So in this case, inside of the absolute value lines, you have to remember that what the math is showing you in that function is actually backwards from what is actually happening. For horizontal translations, it shows that, of course, the x minus c, that number that we are adding or subtracting, is inside of the function, and it is, of course, going to generate the opposite effect of what it shows, okay? And there's a nice graph example of this here as well. On this next page, we've got this yellow table, which is a summary of all the translations, both up, down, and left, right. And it's a pretty handy reference, so just keep in mind that this is here. And they've even given us a little reminder about how errors frequently occur with horizontal shifts, okay? And that is because they are backwards, and we know that people tend to forget to handle that the correct way. So always be on the lookout for that. So now we're being shown a example where there are multiple transformations, and the key thing for us here is going to be identifying them and then applying them in the correct locations. Okay, so I'm going to start with, hey, here's the original numbers again. Okay, and we've been using these for a while now, so I'm sure you guys have them down. 2, 1, 0, 1, 2. Okay, and these transformations, so first let's start with this negative. That is a reflection, and this is 1 unit up. Okay, so we're going to change that to negative on the y, and then we're going up 1 space. Okay, and on the inside of here, we've got that plus 3, which is actually going to the left 3. So that is x minus 3. Okay, and so what we do is basically just individually apply these, and we get some new numbers that we can graph. So if I do x minus 3, we just take all of these points and subtract 3. Negative 4, negative 3, negative 2, and negative 1. And then for the y values is interesting. We're going to flip the sign. We're going to make it negative, and then we're going to add 1 to it. So 2 becomes negative 2 plus 1 is going to be negative 1. Then we're going to have 0, 1, 0 again, and negative 1. And so if we graph this, you're going to see kind of interestingly, this point is actually at here, and we kind of get something like this. So it has a few transformations on it. First, it's been moved left 3. It's also been moved up 1. These are both translations. And it's been reflected over the x-axis. Okay. And so you can see there was kind of a lot happening in this, but we just individually apply the transformations to the values, and you'll be able to find your new graph. Okay, so in this case, guys, part B, this one's got a little bit of a trick to it. So you can see that there are two things happening inside this parentheses, or sorry, inside the absolute value lines, and those are both horizontal changes. However, it's very important that we factor this 2 out from here, because otherwise you are not seeing the correct picture. So this 2 is going to be a horizontal shrink by a factor of 2, or 1/2, okay? Because we're going to divide by 2. And then this minus 2 is going to go right 2 spaces, okay? And because of that horizontal shrink, it looked like it was going to go 4 spaces over, but it's actually only going 2 because the graph itself is smaller, okay? So let's set it up, exact same idea. We're going to go x, absolute value of x, which is negative 2, negative 1, 0, 1, 2, 2, 1, 0, 1, 2. Again, these are just convenient points that are very easy to work with, and you can find those in your previous chapter's notes. So here we're going to do 1/2 x, so x divided by 2, and then we're going to add 2 to it. So both of these are backwards. It says times 2 minus 2. We're actually doing divide by 2 plus 2. Okay, and we're going to have a y value that's unchanged, okay? And so basically we get -1, that's going to be 1, -1/2 plus 2 is, we'll just use a decimal, we can just say it's 1.5, 0 plus 2 is 2, and this is going to be 2.5, and then 3, okay? And then our y value is unchanged to 2, 1, 0, 1, 2, okay? So if we go 1 and 2, 1.51, 2, 0, 2.5 is 1, and then 3, 2. So it's a little bit tight here, but you can kind of see me drawing this graph. And so approximately this is what our graph will look like. So you can see it's got that horizontal shift. It's definitely skinnier and shrunk horizontally compared to the original graph was. Okay, so just be on the lookout for a situation where you may have to factor that transformation out. Okay, over here we've got two y transformations. Okay, this time they use the x squared function. So x squared function original points are a little bit different. Okay, so we've got x and x squared. So we'll just kind of start with the same numbers, but these are all squared. So we get 4, 1, 0, 1, 4. Okay. Now, there is nothing inside of here with this x. And so both of these changes are happening to the y values. Okay. So leave that x value alone. We've got 1/2 y plus 4. Okay. And so what we're going to do is we're going to divide by 2 or multiply by 1/2 and then add the 4 to that afterwards. We just copy these x's down. These are just the same numbers that we had originally. So 1/2 is 2 plus 4 is 6. 1/2 is 4.5. Okay, it's going to be 4, 4.5, and then 6 again. So these are kind of, the values tend to repeat themselves in here. So, and what we're going to see is kind of that parabola developing here. And you can see it's kind of a little bit flatter looking than a parabola normally would be. It's kind of wide, okay? And so if you wanted more detail, if you wanted a better picture, you can still plug in some more information and kind of go through it like that. But this is essentially how you would apply the transformations in order to come up with the graphs, okay? So in black, guys, I've been using what I call the parent points. They are the values from the original baseline or parent function, whatever you want to refer to it as. You can find all of those in the charts in section 2.6. Okay, and then in this last example, guys, we're going to do some transformations based off of not just an equation and not just the origin points, but off of an entire graph. And so basically, it's pretty easy. All you do is you take your original graph, your f of x graph, and apply whatever transformations to it. So this first one says, let's go up 3, right? So all we need to do is take all of these points and we're going to shift them up 3. So we had -4, 0. We're going to have -4, 3. We got -2, 2, which is now going to be -2, 5. And then 0, 0 goes to 0, 3. And I'm just kind of moving the easy corner points because those are going to be the easiest for me to read. So we had 3, 0 up to 3, 3. And so basically, once I've done that, I can kind of fill in the same shape. And I know mine is not going to be as nice as the printed one. But roughly, we get something like this. And you're like, oh, okay. So it looks kind of similar. It's just the same graph, but shifted up 3 spaces. Okay, and we'll apply the same logic to the next couple here. And so we've got now 3 spaces going to the right. Okay, so if you kind of follow from the original graph, there are, I think, like 5 major points that I use. -4, 0, -2, 2, 0, 0, 1, -4, and then 3, 0. And so we'll just apply the adjustment to these and then kind of connect the dots. And so again, f of x plus 3, this is left 3 spaces. So basically just take all of these points and shift them left 3 spaces. My negative 7 is going to stick off a little bit. So negative 2 is going to become negative 5, 2, negative 3, and then 1, negative 4. We'll slide over 3 spaces, and there we go. And so this time now you've got something like this. Bounces up. And I'm just trying to copy the shape as best I can, okay? But I'm hitting all like kind of the critical points here, okay? And now on this one, we're going to go right 2 spaces and 3 spaces up. Okay, and so basically you can just start like, okay, here's negative 4, 0. Let me go right 2 spaces. Let me go up 2 spaces. Boom. Start from negative 2, 2. Go right right 2 spaces, up 3 spaces. Okay. It's a little bit low. Okay. Same thing. 0, 0. Go right 2 spaces, up 3 spaces. 1, negative 4. Go right 2 spaces, up 3 spaces. And then 3, 0. Right 2 up. Okay. And once again, we've kind of got that same looking graph. Okay. And so again, all we're doing is take the original points, the easy ones that you can kind of see from the graph, and then shift them the way that you want. Okay. The last one that we had on there was actually a reflection, and that one's pretty easy. So again, these are the points from the original graph: negative 4, 0, negative 2, 2, 0, 0, 1, negative 4, and 3, 0. So I just pulled those from the example graph that they had. And basically, when I make it negative, I'm just going to flip the signs on the y values. So negative 2 becomes negative 2, 0, 0 again. 1, negative 4 becomes 1, positive 4. These are all going to flip, and then 3, 0. So now my graph is kind of like upside down. Same idea, just kind of an upside down version of it. Okay. This last green box is a pretty good summary of all the transformations, so something helpful for you to reference back to. Okay. All right. Well, good luck and happy studying with this.